This is a jet engine. It is made of 2,500 different parts and held together by thousands of bolts and screws. This is also a jet engine. However, it is entirely made in one piece, designed by Professor Xinhua Wu in Monash University in Australia through additive manufacturing. This one-piece innovation not only removes the stress concentration by eliminating all the screws, it also significantly reduced the time cost from 6 months down to 1 or 2 weeks. Meanwhile, additive manufacturing also reduced about 90% of metal waste when compared to traditional subtractive manufacturing, for example, machining. However, due to the extremely high cooling rate, the components made through additive manufacturing have a totally different microstructure than the traditional casted ones. The long-developed post-heat treatment process for traditional methods no longer works for the additive manufacturing. This can potentially cause detrimental failures, which significantly limits the usage of additive manufacturing. As a result, there's an urgent need to develop a new post-heat treatment profile specifically for additive manufacturing. This summer, I'm working with Dr. Sheng and many other PhD students in the PMMD lab in the University of Pittsburgh to address this problem. Through computational simulation, physical experiments, microstructure characterization, and mechanical testing, I'm able to find the best post-heat treatment profile for additive manufacturing metal components that leads to optimal performance. Developing a new post-heat treatment profile for additive manufacturing that leads to optimal mechanical properties and minimizing the energy consumption allows the greater general public to recognize the strengths of additive manufacturing and choose this greener and more powerful innovation.